putting up so much global warming pollution that it's trapping a lot more of the sun's heat inside the atmosphere, raising global temperatures dramatically, and cooking, wilting, drying out, parching the most vulnerable parts. It's making hurricanes stronger.
Rising sea levels threaten every coastline.
How can we distinguish between variations due to natural causes and those variations of the climate that are induced by human activity?
None of the major climate changes in the last 1,000 years can be explained by CO2.
We would never suspect CO2 as a major climate driver.
With the developing world and the poorer countries of the world who need to develop. So we've got to help them develop in a low carbon way. That means transferring the technology we have. They can develop in a way that is far more fuel efficient and carbon efficient for themselves.
Our generation's response to this challenge will be judged by history. If we fail to meet it boldly, swiftly, and together, we risk consigning future generations to an irreversible catastrophe.
And actually, there are parts of the Earth's ecological system that are shockingly vulnerable. The atmosphere is very thin.
But this is a new day. It is a new era.
Renewable energy is a term that describes energy harnessed from natural resources like the sun or wind. They are finite and have little negative impact on the surrounding environment. There exist a variety of renewable energy resources in which natural energy flows can be used to provide energy for various uses. At present, 12% of the world's total energy expenditure is provided by renewable energy sources.
According to the Met Office, climate change refers to a change in the average state of the climate and/or the variability of its properties. Throughout the Earth's history, there have been noticeable fluctuations in global temperature. Although since the last ice age 11,000 years ago, the temperature of the Earth has remained fairly stable. However, since 1750, the amount of atmospheric carbon dioxide has increased by 31%.
So what is actually causing this unnatural increase in carbon dioxide levels and the idea of global warming? Greenhouse gases such as methane, carbon dioxide, nitrogen oxides and CFCs have the greatest effect on the climate as they influence the net heat balance of the Earth. Thermonuclear reactions that occur in the sun emit a variety of radiation types towards the Earth at the speed of light. As this radiation passes through the Earth's atmosphere, it is absorbed by the particles and gas. Most visible light reaches the Earth's surface and is transformed and re-radiated as infrared radiation. The atmosphere permits some infrared radiation to be re-radiated whilst trapping a percentage. The greenhouse gases mentioned before absorb certain infrared wavelengths that are being re-radiated, thus trapping heat in the troposphere and acting like a greenhouse. 31% of solar energy emitted from the sun is reflected back into space by cloud cover, particles and gas, or by the Earth's surface. 69% of solar radiation is absorbed by the troposphere. Higher emissions of greenhouse gases, therefore, result in more heat being trapped and a global warming. The greenhouse effect is a natural process, and without this natural occurrence, the average surface temperature of the Earth would be minus 20 degrees centigrade.
There are three types of fossil fuels: coal, crude oil and natural gas. At present, humans are dependent on fossil fuels for 88% of our energy needs. The highest population growth rate combined with the highest ever consumption of fossil fuels results in a high energy demand, but we have a diminishing supply. Fossil fuel reserves are more than adequate to meet projected energy growth until 2020. However, to exploit them, all large investments are necessary in infrastructure and production. Fossil fuels are formed by anaerobic decomposition of dead organisms. This process takes place over many hundreds of thousands of years. Fossil fuels contain a high amount of hydrocarbons, which when burned release greenhouse gases which contribute to climate change. If we continue to consume fossil fuels at this rate, the volume of greenhouse gases being emitted gives the potential risk of a positive feedback mechanism. For example, water vapour is a greenhouse gas. With an increase in CO2, the atmospheric temperature will rise, which increases the atmosphere's competence to hold more water vapour, and this will result in a global temperature rise. Because of an increase in natural greenhouse gases, this will give a multiplier effect. Positive feedback mechanisms in relation to climate change mean that response will lead to increased warming. Fossil fuels have limitations, the main one being the pressure they exert on the fragile climate. This is why the pursuit of alternative fuels is so desirable. They will produce less greenhouse gases and thus decrease the global warming, so any potential correlation between human-induced warming and climate change will be eradicated. Therefore, we will prevent climate change induced by humans, and any observed change will be the result of the Earth's natural fluctuations.
At present, nuclear energy provides around 6% of the world's primary energy. One of the main benefits of using nuclear energy is that it does not create carbon dioxide. So, is nuclear power an answer to combating climate change? Energy is created when the nucleus of some radioactive elements, such as uranium, is split, which results in the release of large amounts of heat, which is then used to boil water, creating steam similar to conventional fossil fuel power plants. Nuclear energy at this point would seem like an ideal alternative energy source, as there are no greenhouse gas emissions. However, the main disadvantage of nuclear energy is the nuclear waste generated by nuclear reactors. In the UK, the total volume of nuclear waste is 470,000 cubic metres, including waste that will arise in the next 100 years from existing power plants. The concern is, what can be done with this highly radioactive nuclear waste? Nuclear accidents such as Chernobyl in 1986 and the 3 Mile Island in the USA in 1989 highlight further dangers of using nuclear power. Exposure to radiation can be life-threatening. However, the benefits of nuclear power still make it a viable alternative to the mass use of fossil fuels.
One of the main forms of renewable energy is solar power. Most sources of renewable energy obtain their energy from solar radiation either directly or indirectly, with the exceptions being tidal and geothermal energy. There are a number of ways of obtaining solar energy, the most common being from solar panels. The benefits of solar energy are evident. The energy used to manufacture and install solar systems can be recouped in around 1.2 years, a remarkably short amount of time. Furthermore, solar panels produce electricity silently and have low levels of visual disturbances. In some cases, excess energy created from solar panels can be sold to utility companies for electrical credits. Photovoltaic cells are useful as they can be used in outlying rural areas to provide power where there is no grid electricity. There also exists a number of disadvantages with solar power. David Elliott highlights the fact many people are unwilling to pay the startup cost of solar panels when cheap natural gas heating is available, as the offsetting cost will take up to 10 years. The manufacturing of photovoltaic cells often involves hazardous chemicals which are damaging to the environment.
Wind power is the fastest growing renewable energy technology, with a global increase of 34% per year. Wind turbines harness the wind's energy in propeller-like blades and are often connected to an electrical grid. The benefits are clear. However, there are a number of negatives. With regards to wind farms, each turbine must be equally positioned as not to cause turbulent interactions. Between 5 and 15 blade diameters are usually required. As a result, wind farms often take up huge amounts of space and are aesthetically unpleasing. The aesthetics and noise pollution of wind turbines makes the positioning of wind farms difficult. This issue can be resolved by the construction of offshore wind farms, of which the UK has 101 around its coastline. Furthermore, wind is unpredictable and will not give constant supply of energy, so the energy created will not be sufficient enough to supply a large amount of people. Subsequently, wind on its own will not be able to sustain an entire population.
Tidal barrages rely on tidal movements which occur twice every 24 hours due to the gravitational forces between the sun, the moon and the earth. A tidal barrage is similar to a dam. Typically they are built across a bay or an estuary that experiences a tidal range in excess of 5 metres. The movement of water through the barrage creates energy. The disadvantages are as follows. As there are only 2 tides a day, tidal power cannot be continuously generated, and not all power generated can meet peak demand. Existing ecosystems can be altered and damaged when tidal barrages are created, making them an environmental concern. As with most renewable energy sources, cost is also an issue. A proposed 10-mile barrage across the Severn estuary would cost up to £15 billion, although potentially providing up to 5% of the UK's electrical requirements. However, if fully exploited, around 20% of the UK's energy needs could be met by tidal barrages.
Hydroelectricity is a process whereby the potential energy of a river is converted into kinetic energy in a turbine which drives a generator, creating electricity. Hydroelectric power supplies about 20% of the world's electricity. The construction of dams and reservoirs has widespread ecological effects. The water quality around dams is often reduced as the amount of oxygen dissolved is lowered. Combined with the sediment and nutrients trapped by the dam, it creates undesirable areas for aquatic growth. The main benefit of hydroelectricity is that it can be mostly supplied on demand due to the predictability of river flows, and the system can be automated once constructed.
In the UK, 21% of greenhouse gas emissions are emitted by transport systems, mainly that of privately owned vehicles. This is second to the burning of fossil fuels for energy, which contributes to 65% of greenhouse gas emissions. Electric cars have existed for generations and are continually being developed. The Fisker Karma is a specific example of the application of alternative energies in transport. The car is rear-wheel drive and produces 408 horsepower and a top speed of 125 miles per hour. It is staged towards becoming completely independent of fossil fuels. The idea for it was taken from the principle that heavy machinery pulls large loads with electric power. However, when this is applied to a lightweight car, then all the energy will go towards acceleration. It can do an impressive 0 to 60 without burning a drop of fuel. The Karma is able to recharge itself whilst in motion, which is an improvement on previous attempts at successful electric cars. Furthermore, it has a solar panel on its roof, providing more energy and from a renewable source. The main source of energy comes from regenerative braking, which is the conversion of braking energy to electrical energy. Like a kinetic energy recovery system, but when the brakes are applied, energy is transferred to a flywheel, which charges a small generator and will feed a battery instead of a boost of horsepower. It is the entirety of the horsepower, and this will make the car go. It also has a small 4-stroke engine averaging 100 miles per gallon, which can be used if all the electrical energy generated has been consumed. The expense of the car is around $87,000 US. This highlights the cost of using alternative energies. However, the Fisker Karma is an example of sustainable yet efficient technologies which applies to the use of alternative energy.
Alternative energies are being developed around the world, more noticeably by well-developed countries such as Germany and Japan. Aside from the already mentioned renewable energy sources, there are also development of other renewable resources such as geothermal energy and biofuels. The benefits of alternative energies would seem to outweigh the drawbacks. However, the UK, which is an abundant source of renewable energy, is developing renewable resources slowly. According to a study for the UN Conference on Environment and Development, renewables could supply 60% of the world's electricity and around 25% of its heat requirements by 2025. The potential for alternative energies is extremely significant. However, in order to exploit renewable resources fully, the drawbacks must be addressed. The development of sustainable strategies are essential to combat the effect of climate change and reduce global warming. Conservation also plays a vital role, along with alternative energy, in providing a sustainable energy supply and demand system. There is still intense debate over the cause of climate change and global warming. The Earth's climate is influenced by a variety of factors such as volcanic eruptions and solar variations, to name but a few. Natural fluctuations have occurred throughout the Earth's history. If global warming is a natural process, therefore, should humankind invest time and capital in alternative energies or ways to combat the inevitable destruction effects of global warming?